What's up, 7th graders? It's Mrs. Talati here representing Mrs. Servati, and it is just me today. Mrs. Cervantes has a meeting, so she'll be with me hopefully for 5.1. Today we are covering 4.3, proportional relationships and graphs. Your essential understanding for today is I can use graphs to represent and analyze proportional relationships. So in your guys' key terms section, I'm going to try and help you tie it all together. The 4.1, the 4.2, and then we'll roll to the 4.3. So what I'd like you guys to do is we're just going to kind of build a mini table to help you, again, connect everything that we've been doing in the 4.1 and the 4.2. Okay, and then water, I don't leave myself a lot of room, but that's going to be gallons, okay? So I'm going to give you a value of 2 and 10, 3 and 15, 7 and 35, and 10 and 50, okay? Now follow me on this. And this is things that you might want to add into your questions. But what I want to do first is I'm going to identify this as the X and the Y, okay? I'm going to pick my first set of numbers, and I'm going to write this as 10 gallons to 2, I think we're talking about hours. Okay, I'll put an H in here for hours. Okay, now listen, this is, and this is where I want you guys to label, this is our rate, okay? Our rate is 10 gallons for 2 hours. Well, if I divide 10 by 2, I end up getting 5 gallons for 1 hour, okay? This is our unit rate, because it's a per 1 unit, right? This is also, well, let's go back and check. So what I'm going to do real quick here is make sure that my y over x's, 15 over 3 is 5, 35 divided by 7 is 5, and 10 over, or 50 over 10 is also 5, okay? So what you're going to see is that this is not only the unit rate, this is also our K value, okay? And I'm going to write here, K is the constant. It is our simplified ratio. 15 over 3 is 5, 35 over 7 is 5, 50 over 10 is 5. So our K in this specific problem is 5, okay? So again, we're connecting it back to the unit rate. Well, my equation for constant of proportionality is K equals 5x. So this K, all I'm doing is replacing this number for the K variable. So my equation for this one is y equals 5 times x. So again, you saw in 4.1, we covered the rate, which then took us to our unit rate. And then in 4.2, we looked at our K being our, I should even write it over here. Our K is our y over x, right? That we then translated into our formula, y equals kx. And then today we're going to tie it into graphing, okay? So it all is connected. That's really what we want to see you guys understanding here, okay? So let's look at our first example. Example 1 says a house cleaning company charges $45 per hour. Is the relationship a proportional relationship? So what we're going to do is, this one already told us that for 1 hour, it's going to cost us $45, right? Then for 2 hours, we can say that 45 times 2 is going to give us 90. For 3 hours, we are going to charge us, or it's going to charge us $135. For 5 hours, it's $225, and for 8 hours, it's $360. I don't want any of you guys to be thinking to yourself, like, how did we get that? So let's tie it back, okay? We are looking at our time being our x and our cost being our y, okay? So we take our y over our x, which is our k. Our k is our y over x. 45 over 1 was our constant, so our K in this specific problem is 45, okay? That means that if our K is 45, that our equation is y equals 45x. That means now that the y is for the cost, right? And the x is for the number of hours. So here, if I wanted to say, what will it cost me for 5 hours? I say y equals 45 times 5. I can do the math over here. 45 times 5 is 225. And that's where I got the 225 from. Okay? So again, all these are just plugged in for x to get our y. The more hours it takes, the more it's going to cost you. We did not give a graph on this one, did we? Hold on, let me look at the note taker. Okay, so what I'd like you guys to do is you should have some open space. I'm going to erase this. And if you don't have open space on top of the note taker, go ahead. I want to undo that. I'm going to erase this because I want to show you how we're going to connect it back to a graph, but I want to leave some of my information here, okay? So in your very best handwriting, we are going to draw, that is not our best handwriting, Talati. Let's try and draw a straight line. This is the positive quadrant of our coordinate plane. So this is going to be our y-axis and our x-axis, okay? We're going to label our x with our x value, which is time. We're going to label our y value with cost in dollars, okay? And what I'm going to do is I'm going to show you guys. So if I look at this table, do you see how my first ordered pair is for 1 hour, it cost me $45. For 2 hours, it cost me $90. For $3, it cost me $135. 5 hours, it cost me, that's supposed to be a 2, 200, one pen, $225. And for 8 hours, it cost me $360, okay? So if you notice, my x's are going up by 1. So I'm going to go 1, 2, 3, 4, and 5. Now because my y's are going up at a constant rate of 45s, I'm going to have this be 45. I'm going to show this to be 90. This is going to be 135, 225, and 360. Hopefully you're watching this video with sound, otherwise those numbers will not make sense. Okay, so my first ordered pair, I go over 1 and up to 45. I go over to 2 and I go up to 90. Over to 3 and up to 135. Over to 4 and up to 225. And over to 5 up to 360. If you guys notice, I have a pretty good line, right? And think about it. If I have 0 hours, do I pay anything? No. There's my 0, 0 in that corner. Okay, so we're starting to tie this back to x and y axis on our coordinate plane. Let's take a look at the second example. The graph shows, where are we at? The graph shows the relationship between time in minutes and the number of miles Damon runs. Write an equation for the relationship. Okay, so what we're going to do is I want you guys to first label your x-axis and your y-axis. That's the first thing we have to know, okay? Second thing I want you to do is build a very nice table. So again, we can connect it all back. We're going to call this one our time in minutes. Now I'm going to label the x here. Here we have distance in miles, and this is our y, okay? Now remember, when we build a table, it goes x to y. So it goes over and then it goes up, okay? So I go from 0 to 10, and 10 went up. So my x is 10, and my y is 1. That means in 10 minutes, Damon ran 1 mile. I'm going to write this here. Let's write it here. Damon ran 1 mile in 10 minutes. Or it could be the same as in 10 minutes, Damon ran 1 mile. Either way, translate the same, right? So this was my first ordered pair. I went over to 10 and up to 1. Okay, so my second ordered pair is going to be 20 to 2. So my second one, I have 20 minutes and he ran 2 miles. My third ordered pair is 25. So look, if I go in between here, it's 25 and 2.5. So 25 and 2.5. And then I get 30. Remember, I go over to 30 and up to 3. So I go 30 to 3. So now watch, we want to double check what is happening here. So remember, my K is my y over x. So I take my y over x. y over x. My first one is 1/10 y over x. I get 2 over 20, which if I divide those by 2, I get 1/10. So that one is simplified, right? I go 2.5 over 25, and if I reduce those down, I also get 1/10. And then my last one, I have 3 over 30, and if I divide those, oh, sorry, I didn't tell you right here, we're dividing by 2.5. Divide by 3, I get 1/10 here. Okay, now follow me, because this is where I will tell you right now, the majority of you will want to write this. You'll say, K is the 1/10, which you're exactly right, okay? Do not flip your ratio. Whatever your K is gets directly put into this formula right here. So all I'm doing is replacing that K with the 1/10, and that is my final equation for that table. Please, please, please do not convert it into a whole number because you think it's wrong. This problem says that Damon ran 1 mile in 10 minutes, okay? You don't run 10 miles in 1 minute, that's impossible. So you've got to go back and say, do these make sense, okay? So what we want you to do is when you get to the try this, you really need to show and prove, like right here, this is an X and a Y. Flip K is Y over X. Prove if these are going to be proportional, okay? Really, really, really take your time to look at whether or not that information makes a proportional relationship. All right, you guys have a great day and try your best on the additional practice.